Hey everyone, welcome to chapter 5. We are cruising through Algebra 1 here. This next section that we are going to talk about is all about linear functions. We're only going to talk about lines in this chapter, and we're going to start off by talking about a whole bunch of new vocabulary. Please take notes in this section. You are going to submit your notes, so use loose leaf paper to copy down everything that's on the screen, or you can print out or fill in the Google Doc that is this exact guided notes for this section. Notes are going to help you remember and learn and conceptually understand what we're learning about. So let's get started. 5.1 is called domain and range of a function, and these are two words that we might not have heard before, so we're going to define them in the section. The first word we're going to talk about is function. A function is a relation where every input has exactly one output value. The function provides instructions on what to do with x. So I have an input, here's our x values, and I put them into the function. The function does something to them, whatever it is, and then when it spits it out, we have our output values. So then in other words, input value is the beginning number that will be substituted into the function, right? This is what goes into the function. And the output value is the ending number after being evaluated using the function. So the function does something to the input and then an output gets spit out. Equations written in slope-intercept form can be called function form, and that's what we want to talk about. We're going to write things in function form. For example, y equals negative 2x plus 4 is in function form. Standard form, remember this, 4x plus 5y equals 20. Not in function form. We would have to solve for y. And we're going to practice that in a little bit. So let's check out this first problem here. It says make an input-output table for the function. Here's our function using these x values. So I've got this table. Input, remember, is our x values, output is our y values, and we're using this function. So we're using these directions right here. Input value, beginning number that we will substitute into the function. So I take my function and I'm substituting negative 2 in for x. So I'm going to have y equals 2 times negative 2 plus 3. Notice the x is gone, right? This equals x. So why would I keep x if I know x is negative 2? I substitute it in for x, and then I'm just evaluating. 2 times negative 2 is negative 4, plus 3 gives me negative 1 is my output. And then I'll show you again. I'm going to use the same equation, same function. Y equals 2x. This is my new x. Substitute it in. And I'll evaluate. 2 times negative 1 is negative 2 plus 3. That gives me 1 is my output. Here's my work for 0, 1, and 2. And you can see my function. I input the value in for x, and then I evaluate. Let's check out this one. Here my input is negative 2. I'll use my function. So I'll have y equals negative 2 squared minus 1. Notice in both of these, guys, I put parentheses. Anytime we input or substitute anything into a function, we must use parentheses. And this is really important when we've got exponents, because now I have to do negative 2 squared. Remember, negative 2 squared is negative 2 times negative 2. Gives me a positive 4 minus 1 gives me 3. Is my output. If negative 1 is my input, I'll input that in for x. Negative 1 squared is 1 minus 1. This gives me 0 is my output. And then I already have these ones done. Something to note, guys, your inputs are your x values, your outputs are your y values. These can create ordered pairs. So this would be a point negative 2, comma, negative 1, because we know an ordered pair is an x, comma, y. This would be point negative 1, comma, 1, x, comma, y, 0, comma, 3, 1, comma, 5, 2, comma, 7. Inputs and outputs are just ordered pairs. So now that we're in Algebra 1, though, we're not really going to be using the terms input and output values. We have more mature names of vocabulary words for this. Domain is the set of all possible x values. That's your input. Range is the set of all possible y values. That's your output. Guys, you will talk about these words for the rest of your math lives. We need to know what these words are, domain and range. So let's check out this example. It says the table below shows the number of adult and child tickets sold for a school concert. Rearrange the equation into function form, then find the domain and range. So here's our function. First thing we have to do is get it into function form. Remember, that's slope-intercept form. Remember, we have to solve for y. So let's write this down. 4x plus 2y equals 16. First step, if I want to get that y by itself, I'm going to subtract 4x on both sides. And I'll get 2y equals negative 4x plus 16. I'll put the negative 4x so it looks like slope-intercept form. And then I'm going to divide everything by 2 to get that y by itself. There's my function form. My domain. Let's go back up for vocab. The domain is the set of all possible x values. What we're doing is literally listing our x values. Here's our x values in the table. We use our curly brackets when we list something in mathematics. I can't just have random numbers here. And I'm going to say my x values are 0, 1, 2, 3, and 4 in curly brackets. My range is the set of all possible y values, curly brackets when we list something. And we're going to list this from least to greatest. 0, 2, 4, 6, 8 is my range in curly brackets. Something that we want to see, it says, why is x equals 5 not in the domain? Well, we can check this because we can use our function form. If I set x equal to 5, I'm going to get negative 10 plus 8 gives me negative 2. Notice negative 2 isn't possible for number of child tickets. I cannot have negative 2 if that's a y value. I can't have number of child tickets be a negative number. Okay? Why is x equals a half not in the domain? Well, it's not possible to have half a ticket. We can't do that. Okay? So we have to think of the context of some of these problems. Let's check out some other examples. It says find the domain and range of the relations below. So if we look at A here, whoops, sorry everyone. If we look at A, remember domain is my x values. I literally just list my x values. 0. I'm going to go least to greatest. 3 and 9. And I only need to list it once. My range, I've got negative 2, 1, and 4. That's my range. You can see my domain is here. Here's my x's. Whoopsies. X's for my domain. Range 5, 5, 4, and 4 is my range. Notice now, so that's if I'm just given a set of ordered pairs, right? These are ordered pairs. I can find the domain and range. Okay, no problem. I'm now given a graph. I can still find my domain and range just by looking at our x values and our y values. I don't know why this keeps on happening. I'm so sorry. Of our points. So if you look at this point right here, the x value is 1. Look at this point. What's our x value? It's 3. This point, our x value is 5. This point, our x value is 7. This point, our x value is 9. We can still find our domain and range from a graph. This is our y-axis, so let's find our y values. I'm going to go least to greatest. I'm going to start at this one. Our y value is 1. Here, our y value is 3. Here, our y value is 5. Here, our y value is 7. Here, our y value is 9. We can still find the domain and range from a graph. Same thing here. Look at my x values. 2, 3, 4, 6, and 9. And my y values. Label your axes right away to help you. Label your domain and range. If you need to go like that, go like that. Okay, great job, guys. This is 5.1, finding domain and range.